Welcome back to the Developer's Guide for Windows 10 Insider Preview. I'm Jerry and this is Andy, and we've been talking about all kinds of cool things you can do inside your Windows app. Now we're going to talk about how a Windows app can help another Windows app.
Indeed, yeah. So this is a kind of extension of what you've been talking about in the last session of background tasks. Special case of that. So in this session, we're going to look at obviously what they are, how you program them, how you debug them, and some implementation details that will make you use them more effectively and create a good experience for developers who are using your app service as well. So a lot of stuff I want to run through. We're going to go through it pretty quick.
All right, let's start at the very beginning.
Okay, so
what are they?
What are app services? Well, you can think of this as a bit like web services on device. Okay. Web services on a Windows 10 device. So, we've already got a number of different ways that, a number of different APIs that allow apps to interact with the platform, which is like the, getting contacts and email. And there's Launch URI Async, which allows you to launch into settings pages and offline maps and the store. Loads of ways where the platform exposes the connection points for your apps to take advantage of. And there's also a bunch of APIs that allow one app to interact with each other in various ways. So there is URI association. So you can have an app that registers, say, I know how to handle a particular URI. So essentially you cook up a custom URI like my custom protocol : and one app can register for handling that, and a client app can make a call to that URI, launch that URI, and pass some information and get the other app to activate.
Right.
So that's one foreground app launching another foreground app. Launch file async, same kind of thing, but obviously files are involved there. There's another one called Launch for Results, Launch URI for Results. This one, those three we covered in a session all about app-to-app communication.
That's right.
And those tend to be talking about a foreground app launching another foreground app, and the for results one is the launched app can then call back and send a result back to the initiating app. So those are all foreground ones. App services is a way of running having a background task invoked from a different app. But they are long-lived. It's kind of very much like the life cycle of a web service. Mm-hmm. So yeah, think of web services on device, and this is a diagram that looks like it. So you can have a couple of different client apps that can make a call to that other app's background task. And I'm showing there a graphic with a kind of a blurred out foreground app. So this is a regular UWP app. It has got a foreground app, but actually that's kind of
inconsequential.
Totally inconsequential, that's right. Apart from perhaps the manifest which declares the background app service.
Maybe it could be settings or setup or initial authentication.
It could be some stuff in there, but really the important stuff is all that's happening in that background task. And
it is important to say you must have a foreground app. There is no background only.
Not at this time, no, that's right. Yeah.
That's right.
So what can you use this for? Well, use your imagination. This is going to be actually one of the most exciting new technologies we've got in UWP. It does allow you to build this web of apps idea where you can now start shipping apps that are just there to provide some non-visual, some kind of services that other apps can take advantage of. Think of a barcode scanning kind of example where a foreground app can capture an image and just send those bytes over to a decoding app service, and you can just use that over and over, and all the smart stuff about decoding it sits in that app service. And because it's an app, you can obviously revise it, you can issue updates, and it's updated through the store mechanisms just the same as anything else. So a very nice way of making sure a good service and you can maintain it and provide.
Decoupled nicely, yeah, that's cool.
Yeah, that's right. So it's all cool, and you can do some interesting stuff. And there's another example here where you could have an app service. Think of an enterprise suite of apps. This is something that our enterprise customers have asked about for a while. Is effective ways of having a suite of apps that work together and cooperate to solve a particular line of business situation, a particular enterprise scenario. You could have app services that are acting as caching or on device that are talking to a cloud backend. That's one kind of thing you could do. Or an app service that encapsulates some specific, NFC reading capabilities or something like that. And again, you don't want to keep building this over and over into your foreground apps. You can just provide that as a service that other people can then take advantage of. So they could be private to your scenario, or you could issue a public public, you could create an app service that you just distribute through the public store, just as a kind of a service out there for other developers to take advantage of. So it's cool stuff. Lots of ways of interacting with these things. Let's have a quick look at the code. So the essentials here is that you have an app service connection at the top there. So you instantiate an app service connection, and that takes on it the name of the target service and something called the package family name. So this is when you submit an app up to the store, when you register it with the store, you get given a package family name, which is this combination of the publisher and the actual app name itself, and they are guaranteed unique. So every app has a unique package family name.
Where do you get the app service name?
The app service name, we'll come to that, is declared in the manifest of the app that is hosting that app service. So that kind of...
The developer makes it up?
Yeah, absolutely. It's just the developer makes it up. So there's no kind of central repository. You can't sort of register an app service name for your own use. That's absolutely true. So you probably also want to... the package family name, though, is unique. So the combination of the two, the app service name and the package family name, you're specifying those on your app service connection, means that it's going to go to the intended app service.
I see.
And then you open an async connection to that app service through the app service connection, and it will try and make that connection. And then you communicate with that using this very very versatile but easy to use value set. This was a new type that came out in Windows Store 8.0 WinRT apps, and it's a lightweight dictionary. So you just store in it. It's a string key, and then you can put any serializable object into that value set.
That's right.
So you can send that over, and it can be arbitrarily long. You can put a number of different values into that. Send it over using the send message async to the other end. And then you just, that's an awaitable, so you're just waiting for the app service to do its processing and then give you an answer back. And then you look at that response, and you can get, and what you will get back from the app service is yet another value set, which will have the response in it. So you can then extract that response, and you get the data that you're expecting. And not every app service will return a data, but I imagine in most cases you'd expect a kind of at least an OK or something. So that's kind of the essentials of a client. So what about the service? This is a background task. So it inherits from iBackground tasks, just the same as any other. And as in case in every other, the key method in here is the run method. And you will do typically sort of things that you might do in any background task. So you'll probably get a deferral, so you can then potentially make some calls to async in here. But this isn't where the smart stuff happens. The key thing here is that in this run method, this is the kind of bootstrapper for your app service, and this will run, if your app service isn't running, this will execute the first time it gets invoked. So the key thing here is that bottom line that's highlighted is that you will hook up a request received event handler in there.
Oh, I see. So the background task that works as the app service runs immediately and then sits and waits for this request received event to fire.
Exactly. It sits there like a web service, sitting on a web server. So this is the kind of invoking code. But thereafter, what we're talking about is the logic you put in your event handler for that request received event. And all calls to your app service come in here. And the typical pattern, I mean, if you remember, from the client slide, we're sending a value set, which is just this dictionary of values. And typically, what you might want to do, this isn't, you're not required to do this, but the pattern we've got here is that you will have in that value set an item which has a key of command, and that will be an instruction, some kind of instruction to the app service. So we've got two instructions encoded here in this example. One that's the string key for that is do it, and the other one is quit. So, and you can have as many as you wish in here. The do it is obviously where the code for the processing for this particular app service sits. Again, you want to get a deferral if you're doing any async calls. You'll do your processing, whatever that turns out to be. And then when you're ready to return a result, you new up another value set, fill it in with the values you want to return, and you call on the request object you call send response async to send it back, and that's it. That's the kind of the basic pattern for using an app, for creating an app service.
So pretty straightforward. You have your run method that sets it up, and your request received that just processes every request.
That's it. Yeah. Now, over on the service application, we said there's this kind of inconsequential foreground app that's part of the package. In actual fact, you don't have to have anything in there. It's probably quite possibly never going to be invoked as a foreground app. But the important thing is the manifest that accompanies that, because in there you have this extension, which is a Windows.app service extension. And the entry point in there, just the same as any other background task declaration, is the entry point of that background task, the one we just looked at with the run method in it. But the other very important thing is the app service name. That is the name that the client has to put into that when it has to specify when it's making a connection to this app service.
And there's no requirement around that name other than it be unique inside your app.
That's right, yes. So if you remember, on the client is making a call specifying two things. Not only the app service name, but also the package family name of the app. So that is the unique bit. So yeah, you just need to have a suitable name in here. You could have more than this app could have more than one app service. Absolutely. So just want to make sure that those names are unique in there. That's all.
These are long-lived tasks, I guess, then, because they just sit there and listen and listen.
That's the interesting thing. I'll talk a little bit about the life cycle in a while. But once invoked, it will just sit there and is ready to handle as many requests as get sent to it.
That's cool.
It will get I'll talk about it in a bit, but it gets terminated when the foreground app gets suspended. So they are fairly short-lived, I guess, but the activation cost is pretty low for these things. So the other thing is, you saw there, we talked through that sequence where the client sends a message and the server hooks up a request received event handler and then waits for incoming messages and handles them. You can actually make that two-way. So on the client side, you can also hook up when it opens the connection, here we got the client side code, a little snippet here. This is the client making a connection to the app service. Once it's got that connection, it can hook up a request received on there as well.
Wow.
So you can have a two-way chat thing going on between the app service and the client, if you so wish. So very flexible. In order to debug, so I said when you submit your app service to the store, you get the formal package family name, but clearly you don't want to have to do that while you're just building this out. So just a couple of tips on how you set this up while you're developing this. First of all, to get the package family name, and this is even before you do, so later on you'll associate the app with the store and that will give you the formal name for it. But actually, if you just call package.current.id.family that actually returns, both before and after you submitted the store, returns the current PFN. So you'll get, in debug mode, you get this kind of GUID back, and it's an extended GUID thing. You can see it at the bottom of the output window there. So that's the value you need to plug into the client when you're making a connection to it. So simple enough. If you want to debug your app service, again, this is the same as any background task. You can't just set a breakpoint in it and expect it to hit that breakpoint and suspend. Because you're probably debugging the client app, and it's invoking this kind of service that's running in another app. So the way that you need to actually debug it and actually get Visual Studio to pause on it is you go into the properties of the service application. So this is this inconsequential head, which is looking less inconsequential all the time, at least from a development point of view. And in the debug...
not the head, but the service.
Sorry, this is the service, yes. This is the app, the foreground app for the service, if you like. You go into the properties of that and go into the debug, and there's a checkbox on there, do not launch, but debug my code when it starts. So you just check that, it's normally unchecked, and then you launch the app service app in the debugger. And what will happen is the debugger will start up, but obviously it won't actually do anything because it's waiting now for that app to be launched. So it won't do anything until then. What you do is you run the client, execute the logic that causes the call to be made, and at that point the app service will be activated and the debugger will kick in and you'll hit your breakpoints and you can step through and do all the normal debugging stuff that you want to do.
So as soon as you run this in Visual Studio, it doesn't invoke it waits until it's invoked.
Yeah, and I've got a demo coming up, I'll show you just how that works. So let's do that. Let's run through a very simple example just to sort of drive home how this works. So it's a pretty dumb kind of example, but it's nice for a thing. Here we've got our client app, and I'm just going to run it to show what we're going to do. So this is our normal client app, running it on the desktop, and we've got a simple calculator service, which I can't imagine why you'd want a service to do that, but it's good for illustrating how it works.
Math is hard.
Math is very hard. Addition in particular. Right, okay, this is the set a breakpoint on that, and then we're just going to step through the client side. So I'll put a couple of more values in. So we're still in the client app, and first of all, we're going to call a method in here called ensure connection to service. That does all the plumbing, sets up an app service connection. We specify the package family name and the service name. Open a connection, and then we have a closed event handler, and then we want to send some data to our service. So stepping through here, this is where we do it, send message async. If we get success back, then we've got our response back. So this is where we've got our response already back from that app service. So that's the client side, nice and simple. Just
almost as if there is no service back there, it just magically happens.
Doesn't look like it, does it? So let's have a look at the service. Let's go into here. This is the, first of all, this is the actual app. It's got nothing, just to prove the point, nothing on the main page.
Quite a UI.
Yes, this is the UI to end all UIs. There is no UI. But the important thing is this. And actually, this app actually hosts two app services. We're going to look at both of them. But first of all, this one. This is our, we've got a synonyms one I'm going to use in the next demo. But we're going to use this default one, which is our calculator one. Here we are in our background task. There's the run method, kind of the standard bootstrap code for one of these kind of things. It can be cancelled, so we can hook up an event handler from that. And we are going to now debug it. So I'm going to click that do not launch but debug my code.
Oh, I see.
And then we just start a new instance. So as if you're debugging a regular app, but nothing actually happens now at this point. It's just sitting there waiting for it to be activated. So now I'm going to run my client app, and I'm just going to go into Cortana to go and find it. It's the easiest way. Here we are, running it up. This is not running under the debug. I'm just using this as a launch mechanism so we can send it something to our service, and now we hit our breakpoint.
Nice.
So now we're into debug in our background task, and we can step through it. And down here, this is the app service connection request received. This is the important stuff. This is where our request is going to be actually processed. So here we are in our request received. We step through, we look at the command. We've got a calc sum command, pull the input values out, do our massive processing. We've added them together, send the response back. Yeah. And the response goes back. So you can see how the end-to-end thing works on that. And then we just have another call. This time you see the bootstrap code didn't execute. We went straight into request received because the app service is still alive. It's still waiting there. So that's kind of a run through the basics of an app service. You can see it's pretty simple. There's a few extra things about cancellation that, the system can cancel it in certain circumstances, so you need to handle a kind of a shutdown of the service. We'll talk a little bit about that in just a moment. So more considerations on that. Let's talk about some of those kind of things. So it is activated on demand, these app services. It's actually, at a technical level, it's something called an app service trigger, which is the kind of the built-in trigger. So in the background processing module you did, Jerry, you were talking about all the different triggers.
That's right.
This has its own trigger. It's called an app service trigger. So when the client makes a connection to that service, if it disposes of that app service connection, so it's finished with it, that will cause the service to be terminated.
Oh, okay, so that when initially the run happened, I saw you activate it twice. It didn't run the second time.
That's right.
So when does it shut down?
So it shuts down either when the client disposes of its connection to that service, or if you actually build into the protocol, so you actually send a quit message from the client to the service and say, just kill yourself,
Nice. Quite a message to send.
Yeah, the power, eh? The power.
Wow. We can execute those background tasks. Send that kill yourself message. This is a violent operating system.
It can be. It can be. In your hands, Jerry, it most certainly is. Right, back to this. If the invoking app, the client app, is suspended, that also causes termination of the app service. So they're pretty lightweight things. They come and go. It's no great cost in invoking them, and they just kind of get killed off when they're no longer needed. They get executed. Also, insufficient resources. I'll say that again. Insufficient resources
There we are.
may cause launch failure or service termination.
Rolls Royces are not involved. This is insufficient resources.
So you need to code around that as well. So it's not a guaranteed thing. If the system's stressed, it may not be able to make that connection. Okay, so you saw we using value sets to communicate across to between the two there. So is there any kind of must-do protocol? I already alluded to this. No, you can do exactly what you like here. So it's just a value set which is designed to be a very lightweight. Interestingly, it's so lightweight. It's actually a native object, a value set. And this technology, as a number of others in the platform, can be called from like Win32 apps that we're packaging as Windows apps, or from apps built from other technologies. It's not just store app to store app kind of thing. So
awesome.
Yeah. So this is kind of an interesting thing.
So if I have a Windows app and I have a desktop app, they both call it. Does it invoke in parallel? Or do they queue up the calls?
I don't know the answer to that, Jerry.
You start making stuff up, Andy. Oh, you're too good. You're too good. I believe they act in parallel.
I believe they act in parallel.
If it were my money.
This is why we're a great team. So when I don't have the answers, Jerry does.
I am willing to make them up.
All right, that's good. That's good. So that's the deal. So when you publish, you're defining a communications endpoint, if you like. So you're just defining a way for a caller to send data. And for the other one to send values back. So that's kind of what you're doing. So you need to sort of publish that protocol, if you like. If you want people to make use of your service, you're publishing it out there for public use. You need to sort of just communicate that. But a much nicer way of doing that would be to hide all that low-level communication.
That's right.
Behind a nice, strongly typed, easy-to-use, functional set of methods. And you could probably distribute that on NuGet. Would be a great way of distributing that, so that people can easily program against your service.
And to be clear, when we say an SDK, we mean a class library.
That's what we mean. Yes.
Yeah,
So
we just try and sound really sophisticated with the SDK.
Yes. You saw there's a bit of connection in that the caller must know the package family name of the service. But if you've got an app service you want to restrict who can call it, you could kind of whitelist callers. That would be one way of doing it.
Sure.
So the package family name of the caller comes over as well.
So that prevents it from being misused by other apps who are trying to get access maybe to your data?
Yeah, that's right. So, and you could do even more complicated things if you wish. Use fancy X509 certificate exchange if you wanted to do that kind of thing.
Wow.
What about versioning? Well, this is just the same as, think of this, it's a very lightly coupled interface. It's just value sets. So just think of this like this is exactly the same problem, if you like, as a REST API published out on a service out on the cloud. So the key thing here is once you publish a interface to your service, once you publish the protocol, the way that clients will communicate and interact with your service, then clearly if you want to change that, then you should issue, you shouldn't break the old one, you should create some new, a new protocol for interacting with your service that sits alongside it, a V2 one, so you can still support older clients. So it's no different from the web in that respect. Right, let's have a quick look at a client library. Now, the example here, I've got this on the Microsoft Azure Marketplace, there's this synonyms API, which is nice up in the cloud from Bing. You can call it and get synonyms. So I've got an example. The other app service in this guy, this one here, we haven't looked at yet, calls the synonyms service. And so we can just go and have a quick look at the code for this. There's the normal run method with the startup, but this is where the request received. And you see in here, we've got a command get synonym, and we're using a synonym API, which is got a method on it, get synonyms async, and then we're going to return to the caller. This is one of my own methods. Here we are in the implementation of it, and all we're doing is using HTTP client to call out to the Azure service. I've got to specify an API key, and we get the data back. It's just regular REST calls to a web service. You put this in
an app service, you only have to implement it one place, one time, reuse for everybody.
Exactly.
That's nice.
So here's one way of calling. So I'm just going to deploy just make sure we've got that on the system. We will have, just being defensive there. And let's run the client. and we're going to make a call to it. So this is the synonym service thing, so we can put in CTAC and find out what the synonyms are. It's calling a service, going over the cloud, and there we are. We've got CTAC, Seattle-Tacoma, SeaTac Airport as being the synonyms for that.
That is incredible.
So that's nice.
What a neat service.
Yeah. But we can improve the client side a little bit. So here's the logic that we used. There's the UI, first of all. Here's the button, and we're just going to have a look at the code behind that button. I'll go and have a look at the definition of that event handler. And you see here, this is all the usual same client-side code for calling an app service. And all this code, lots of code. There's more code. Here's the name and the package family name, but it's a lot of code. And down here, there's even more code, and there's values set and stuff, and it's ugly, and it does the job, but it's definitely code. And there you go, so loads and loads of stuff. And it works, nothing wrong with it, it works fine. But wouldn't it be nice if we had a nice clean API instead to call it? Well,
yeah, that's messy.
Funnily enough, I do. Here's another project. Here we are, it's another project, and inside it, we've got a lovely little API, which actually encapsulates all of that logic. All of that stuff, all the low-level code for interacting, is all wrapped in this one method, get synonyms async. That's beautiful.
That is really nice.
So what you could do is publish in that client library, put it on NuGet, and over here you could add. I'm going to add a direct reference to that project in here. In fact, I've already got the reference to it.
This makes sure that the callers don't get it wrong.
Exactly. So now instead, here we go. So this is the old one. I'm going to just comment that out, and we're going to substitute it with a call to our client library instead, which is this guy. So we just uncomment that, and that does the same thing in a lovely, clean way. All it does is calls synonyms client.get synonyms async, and just to prove it works, we'll just run it against that one.
That sort of encapsulation just makes sense, especially if you have lots of them, because you can service that NuGet package.
Exactly, yeah. So there on UK, get synonyms for the UK, and that is Great Britain, Northern Ireland. Gosh, you get geography in this as well. How about that?
I've never heard of this UK.
Yeah, it's where I live, Jerry. Good. All right, so that's a nice example of some of the nice things you could do to encapsulate that. So what we saw there, we looked at what app services are, and I hope you agree, this is really exciting.
It is.
We can build a nice web of interacting components sitting on devices. We can service them through the store. We could do client SDKs through NuGet.
And man, I can really see an application for these in a line of business sort of scenario.
That's going to be obviously the primary one, but you can also see some kind of cloud service or something having an app service fronting it.
Yeah.
Rather like that synonym service, and somebody you could publish that out for developers as an easy way to make use of your assets out in the cloud. So.
And it makes sense to have that as a proxy or gateway out to a service, because if they're using that, you can even handle an offline scenario for them.
Yeah, totally. You can keep on adding adding lots of complexity to that and making it really easy to take advantage of some kind of service.
Cool. All right, well, let's take a break here and come back and talk about more cool features. But I think it's lunchtime, isn't it?
I think it is.
Or is it web time? What time? Hey, Barry, what time is it?
It's not food time yet.
Is it time that we talk? You know what? Let's shift gears here.
Yep.
I think it's time that we see some of the cool things that we've introduced to allow developers to write web-oriented applications using amazing new technologies.
Yep.
I think we'll have Jeff come in, actually.
That's right.
Have him walk through some of the pieces that we have here so that you can see what's at your disposal for Windows applications that want to leverage these new Windows or these new web technologies.
Yeah, great. Yeah, so we'll be back after that, and we'll pick up the thread again with some more stuff about the UWP platform.
Perfect. We'll see you soon.
See you soon.